All right, so in example 3, we're given the graph of a population, and we're told that it grows towards some limiting population L. And where there's an inflection point on the graph at the point L/2. All right, so this at the halfway mark, halfway toward the limiting population, whatever that is, at the halfway mark, there's an inflection point. Okay, so it changes concavity at that point. And the question just asks, what's the significance of the inflection point to the population? So we just want to interpret this. If this represents the population over time, right? So we're graphing population versus time. What does that mean? What is the inflection point? How can we interpret the inflection point? All right. Let's just think about this. Now, I'm just for reference, I'm just going to drop a little dotted line here. Let's call this time t1. Let's call it time t1. Okay, so it's at some time this, it hits this point where the population is half of the limiting population, and we're told there's an inflection point. So before that time, before the time t1, the population is growing faster, right? Because this is, you can see that it's an increasing population, right? So it's really increasing along the whole thing. So the first derivative along this whole curve is positive, okay? But you can see that it's in this section here, right here, it's concave up, right? Concave up. So what does that mean? Concave up. Right, the word concave up. So that means that the rate of change of the population over time is increasing. Okay, so the population is growing faster as time goes on until it hits t1. So then after time t1, let me mark that here, you can see that the curve is concave down. So what does that mean? That means that after this time t1, the population is growing slower. So at some point, it's probably hitting the limits of its resources, and it starts to slow down. Okay, the population growth starts to slow down. So this is the graph of the population. The derivative would be the population growth, and then the second derivative would be how fast the population is growing. Okay, so after this time t1, the population is growing slower as time goes on. So what does this inflection point mean? It's essentially where we're changing concavity, so the second derivative is 0. Now, the second derivative is the derivative of the derivative. So it tells us something about, it's essentially a critical point for the derivative of the function. And so you can also see it's changing from concave up to concave down, right? And so at this point, t1, that's as fast as the population is going to grow, right? Before time t1, it keeps growing faster and faster and faster, and then it starts growing down. So the other thing that we can say about this is that the population is growing the fastest at time t1. Right, because it goes from concave up, so it just keeps growing faster, 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 and then after time t1, it's growing slower. So it never gets it. The population growth never increases. The population is growing the fastest at time t1. Okay, and it kind of makes sense if you think of the second derivative as being the derivative of the derivative, then the the inflection point is a critical point for the derivative. So it's a potential maxima or minima for the derivative. Okay. So, all right. I'll meet you in the next video.